So this problem up here is closely related to what we had done last week. I think what the problem was is maybe it wasn't worded very well last week, and maybe not that this is either, but we'll do our best to navigate our way through this. Okay, so this is just a simple, we just call it a clay triangle. Looks like a triangle, and these clay pieces on here, just like what you would see with pottery. Can't clay stand really high temperature? For those of you who are in art, you put it in a kiln, and then that's how you cure your pottery. It becomes well, whichever. But then here is your crucible. Looks like this. It's just something that sits right inside of here, and you put that on a Bunsen burner like this. Some of them actually have a lid, and they're not all the same size, as you can see. I don't know if you can tell from looking at this on the camera, but one of them is actually bigger than the other. As you can see, it just totally fits inside of there. Okay, so not everyone's going to have the same types. Yes. That's what we talked about last week, yes. Okay? So the question was, is we were going to work on this on yourselves, and that's what we made reference to last week. So this is just something that I think maybe I read this somewhere as problems online, and then just had to make up different numbers so we could follow your procedure. So what just follow along, then we'll have our visual aid here. It says, okay, so a student weighs a crucible and the mass is 100 grams. Now whether that's going to be the same as what you see here, that I really don't know. The group adds nickel 2 sulfate until the mass is 240.50 grams. Upon 3 trials, the mass is 77.50 grams of nickel 2 sulfate. So what is the amount of moles of water in the hydrate? Because I don't think the one we did last week, the numbers were right, but the wording didn't match maybe as well as what this one does. Because, and of course, there's so many different ways that you can come up with the mass of the hydrate that you're putting in here. But I would be led to believe that you would follow this same procedure to where, okay, and you might say, well, this is silly. Why do we got to write all this stuff down? But it's more so practice for documenting things, recording data, because that's going to be a big part of, for those of you who take this in college. So what would happen is we said, yes, you could say we have 2 lines here, okay? Then maybe on the second line, it might say, what's the mass of your crucible? Well, we said that's 100 grams, okay? Then you might say, well, we kept adding materials and adding materials, so we put the bigger one on top. So then once you stopped adding, there's really no set amount. You just need to make sure that you record it. So then this group, maybe they put 240.50 grams of that substance in there, okay? So then what happens when you subtract these two? You just get 140, okay? So 140.50 grams. Now this is your hydrate, okay? And this would maybe be on a line. Then what you would need to determine, okay, well, after saying we've got 140 grams of that nickel 2 sulfate in here, you put it on your triangle, and then maybe you weigh it, and it comes out to be, let's say, 91. Yes.
So when you say hydrate, like, is that like everything together?
That's how we explained it last week, yes.
So it's nickel 2 sulfate, but it also has the water.
And it has the water in it too. Yep. So then, like I said, maybe you put it on there for 10 minutes. I don't know. You weigh it, and it says 91 grams. Okay, well, then we would say with this hydrate, that's why we want to say we know we've got nickel 2 in there, and if we've got hydrate, that means you got water then too. So the first trial was 91 grams. I don't know, again, this is just something I'm trying to envision in my head. Because it says after 3 trials, the first one was 91, then maybe the second one was somewhere around 84 grams. Then the third trial might have been, let's say, 78 grams. Then, I know it says 3, but what we see happening here is, notice that these numbers are getting smaller and smaller between, I guess this one should be a lot bigger. We'll maybe say this was 101 grams, okay? So then we see there's a difference of 17. Then we heat it a little longer. Now we see there's a difference of, what is that, 6? And then maybe on a 4th trial, we see that these numbers are not changing as much as what they did at the beginning. Because what's happening is you are boiling all that water out of there. So then after 3 or 4 trials, it's just not changing that much anymore. And because it's not changing, that must mean that all that water is probably out of there now. And again, is this going to come out to be nice numbers that you could find online? Absolutely not. You're probably going to come up with something like this. If you had this in the lab, we know that we've got this in here. If it's nickel 2 sulfate, that would be your formula. And chances are on the bottle, it might say maybe 5 moles of water, okay? But if this was your hydrate, then you do the procedure, you come up with something like, and maybe that's what you come up with. It doesn't mean that you're wrong, because there's no way you're going to be able to replicate that to 100% accuracy. You're just not. It doesn't mean that you're bad at this. It just means you're just not going to get it to 100%. What's the right word I'm looking for? Not efficiency, accuracy. You're just not going to get it to 100% accuracy. But as these trials continue, these numbers get smaller, and then you finally decide, okay, I think this is how much water we have driven out. So then what that means is if this was your hydrate, which had your nickel 2 sulfate and the water, okay, you've done these trials, okay, now we've got 77.50 grams, okay, that's no longer the hydrate. It's anhydride is what we would call this. Okay, so then after doing that, okay, this maybe goes on a line, then there's another one here. Okay, what would we do with these 2 numbers? Now notice we probably see a pattern that we're doing here. What did we do to get this number? Right. So then if after all these trials, since this is smaller, what did we drive out of this crucible? We drove the water out of there, which must mean if we want to find out how much water that is, how do we get that number in grams here?
What?
Okay. Notice we got this pattern here. What did we do between these 2 steps? So what do you suppose you're going to do between these 2 steps then? You're going to subtract again. Okay? So then upon doing so, we get 140.5 minus 77.5. That gives you 63. So that must mean 63 grams. Now anhydride means just nickel 2 sulfate. Okay? And then here we have grams of H2O. Okay? So now, every time we see these numbers measured in grams, we're probably going to change them to what? You're going to change them to moles. But here, okay, we know we got to do this one because we need to see how much water is here in here. And that's why, say, maybe 5 moles of H2O, okay? Then, of these, which one of these, so you got a 50-50 chance. Of these two, which one are we going to convert to moles?
77.
Right, because we don't want this one. Why don't we want?
Because that's your hydrate.
Because that's the hydrate. That has your nickel 2 sulfate and the water in here. So between these two steps, okay,
You could figure out the hydrate and then just subtract. I know you can do that.
okay. So then we subtract here because of these different trials that we did. The closer and closer that these numbers stop changing. And I don't know, I suppose it's possible to maybe decompose this compound too much to where you're getting gas to be let off of there of some sort. Because if there's really that much energy inside of there, can you get rid of some of that oxygen? Maybe to a small amount, but really not a lot. That's why you have to do this multiple times, because what you're doing is driving that water out of there. So therefore we use these two numbers. This is your nickel 2 sulfate converted to moles. This is your water, you convert that to moles. Okay? So then what we see happening is 77.5 grams of nickel sulfate. We're going to convert that to moles. Okay? So, I guess I didn't write the formula up there, but we know that this is 64, this one is around 32, and then nickel, I don't know, is maybe 60, 58, okay. So even though, and I know it's got decimal points behind there, but I think for our purposes, this is going to be okay. So 58 for the nickel, plus 32 for the sulfur, plus 64 for the 4 oxygens, gives us 154 grams of nickel sulfate for every mole of that nickel sulfate. And then what we see happening, let's go ahead and divide that out. We've got 77.5 divided by 154 gives you approximately 0.50 moles of nickel sulfate. So we got to do the same thing for the water then. So what that means is we've got 63 grams of water. Then for every mole of water, we have 18.02 grams of water. And 63 divided by 18.
3.05 or 3.
Okay, so it's 3.496, so 3.50, okay, that's moles of water, okay. So upon doing this, we can't write, well, maybe in your results you would, but we still have one step left yet. Just like what you would do with calculating empirical formulas, to where what you're going to do, it's similar to that, it's not the exact same. Because if we did, we would divide by this smaller number, but it just so happens that that is the same. So 3.50, because that's our moles of water, divided by 0.50 moles of your anhydride here. And notice that comes out to, so if you had this nickel 2 sulfate that had 7 moles of water, again, we just made this number up. I just threw a 5 out there. Okay? So chances are it's not going to come out that exact. It's just not. And it doesn't mean you're wrong. It doesn't mean you're bad at this. Yes?
So why did you do that last step? Because isn't it just asking for the amount of moles? Like, couldn't you just leave it as 3.5?
But you need to have a comparison of both your anhydrite and your water.
Oh yeah, because the mole is like per thing. So
That's correct. That's correct. Okay. So and maybe I was informed that we're going to have missing students. If they did, I totally forgot. Okay. Well, fair enough. So that's really all I have. So we have somewhat of an idea of how it is that we go here. The main thing is you've got to record this as we go. Okay? Again, not everyone's going to have the same size crucible. So that's going to throw things off. Not everyone's going to have the same mole ratio of water molecules in there. That's going to throw people off in different groups. Not everyone's going to have the same type of hydrate. Maybe we'll have some iron sulfate, maybe others have nickel sulfate that might have a different number, maybe some cobalt sulfate, chromium sulfate, magnesium sulfate, any one of those that we'll be dealing with. And you just pick one and you do your best. And I think, like I was trying to explain to another class, is hopefully we can appreciate more than just taking a piece of paper and you're just solving problems, because that's what other classes have done in the past. So we make a sheet here for, okay, just do all this work. Well, one, hopefully it gives you a good work ethic. Two, hopefully we learn something from it. And three, for some of us, we're going to be applying this in the future. So what's unique about this is you're actually doing the process that some of these problems are based off of. And what that means, you're getting raw data from this. You're experiencing the same thing that you've been solving for really all year long so far. Okay? I mean, you're taking your grams, you're changing them to moles, you're looking for some sort of mole ratio of some sort. I think the empirical and molecular formulas is quite a bit tougher than this, but that's something that we would not be able to do in the lab either. Okay. Front row, we're good. Middle row, we're good. Back row, we're good. So perhaps this was either worded a little better or worked through a little better. Because I think the one that we did on Friday is I looked at an old problem that just had numbers on it. So, okay, so I got to make this number this big. I got to change this number. I got to put the wording in this. And then that's where we really maybe didn't know how are we finding the amount of water in here. That was last week. Okay, so that's all I have. We'll catch up to you next time.